The parallelogram law is a mathematical identity equation that relates the lengths of the outer edges of any parallelogram to its internal diagonal lengths. Written out, the law states that adding the squares of the lengths of all four outer edges of the parallelogram will give a result equal to the sum of the squares of the lengths of the two internal line segments. To demonstrate this law, we will analyze a generic parallelogram ABCD with internal angles A, B, C, and D, and internal diagonal line segments BD and AC. By definition, parallelograms are quadrilateral shapes with equal opposite sides, which means that side AD is equal in length to side BC, and side AB is equal in length to side CD. Because of this, parallelograms also have equal opposite angles. So angle A is equal in measurement to angle C, and angle B is equal in measurement to angle D. With these relationships in mind, we will now utilize the law of cosines to associate the outer edges with the internal diagonal lengths. The law of cosines states that for any triangle, the square of the length of any one side is equal to the sum of the squares of the other two sides, minus double the product of the other two sides and the cosine of the opposite angle. Applying this to our parallelogram, which we will now analyze as a combination of two triangles, we can write our equations for diagonal BD and AC in terms of the outer edge lengths and defined angles. Now, by definition, parallelograms have supplementary adjacent angles. Supplementary angles are angles that, when added together, equal 180 degrees. Adjacent angles share a common edge and vertex, but no internal points. If we extend a virtual line from side edge AB outwards, we can see that an adjacent angle is created that is equal in measurement to angle B. Therefore, the sum of angle A and B is equal to 180 degrees, and angle A and B by extension are both equal to 180 degrees minus the other angle. Plugging in the value for angle B in terms of angle A back into the equation for the square of length AC, we get the following equation, and can now use the trigonometric identity cosine 180 minus any value is equal to the negative cosine of that same value to further simplify the equation. Now we can combine the equations for the squares of AC and BD together. Writing out this equation, we recall previously that the length of side AD equals the length of side BC. Plugging in BC for AD allows us to cancel out significant portions of our equation. What we are left with is that the sum of the squares of the lengths of our internal diagonal line segments BD and AC are equal to the sum of the squares of the four sides of the parallelogram, which is exactly what the parallelogram law states.